test techniques, Shri BP Muni, National Representative in Study Committee D1 and GM BHEL, Shri Mustafa Baj, Director Samgor India, Shri A.K. Dinkar, Secretary CBIP and SIGRE India, Shri A.K. Bhatnagar, Director CBIP and SIGRE India. So today's tutorial will be 90-minute session which will include a presentation followed by question and answer session at the end. We request Dr. Rob to kindly take queries at the end. Ladies and gentlemen, SIGRE, as you know, is a unique platform to share experience. Before I start, I invite Shri A.K. Dinkar, Secretary SIGRE India and CBIP for welcome address. We would like to display a film about SIGRE for the benefits of the participants who are not familiar with SIGRE. I request your kind attention, please. I request Ravinder sir to kindly play the SIGRE film.
Construction, National Council of Large Electrical Systems is world for power system founded on November 22, 1921 at Paris. SIGRE deals with the issues related to the development, operation and management of electric power systems as well as design, construction, maintenance of equipments and plants. Mission of SIGRE is to promote and organize in collaboration with experts from all around the world by sharing knowledge and joining forces to improve the electric power systems of today and tomorrow. It mainly aims on coordination of research, exchange of experience, scientific and technical information on the operation and design of electric power systems. SIGRE is an association that promotes the exchange of latest generation of technical knowledge regarding electricity and bringing innovative ideas to support the industry needs. SIGRE has worldwide network of experts from ministries, generating companies, transmission and system operations, distribution operators, regulators, manufacturers and academies. It has gained international representation in nearly 90 countries through national committees in order to provide opportunities or improvement of services supplied to the society. SIGRE has 16 national committees, 95 member countries, more than 10,000 individuals and more than 1,000 organizational members. SIGRE strategic direction are best use of existing system, unbiased information for all stakeholders, environment and sustainability, and future power systems. The challenges are renewable energy sources, growing environmental requirements, limitations to build new transmission infrastructures, architecture of networks, operation of existing power systems, transmission of large amount of power over long distances, cyber security, and intermittency of renewable power generation. SIGRE operates through 16 committees on different subjects having members from various countries. These committees are divided into 4 groups. Group A, Equipment, and the study committees are A1, Rotating electrical machines, A2. Transformers. A3. High voltage equipment. Group B. Technologies and the study committees are B1. Insulated cables, overhead lines, substations, HVDC and power electronics. B5. Protection and automation. Group C. Systems and the study committees are C1. System development and economics, system operation and controls, system environmental performance, system technical performance, electricity markets and regulation, distributed system and dispersed generation. Group D. New materials and IT, and the study committees are materials and emerging test techniques, information systems and telecommunication. The study committee of SIGRE has about 250 working groups which produce nearly 50 technical brochures per year. The work carried out in SIGRE environment is considered as reference being applied to the development of technical standards. SIGRE develops technical knowledge using two main methods: conferencing and meetings, where papers are presented and discussed, and studies carried out by study committees through the work of international working groups on identified industry issues. SIGRE has recently started a series of science and engineering journal. 6 issues have been published in 2015-16. SIGRE has started series of new publications named Green Books. The books on the following subjects are already released: accessories for HV extruded cables, overhead lines, and utility communication network and services. So, why is it especially profitable to join SIGRE activities? Joining a SIGRE working group as an expert always result in a high return for your organization as well as for yourself, all the more so for a young engineer. You become part of a worldwide network of experts with whom you discuss current issues, share international experience, and benchmark your own practices. You are in a position to promote your ideas and weigh on the contents of specifications, recommendations, and future standards. Experts represent all the profiles of the power industry, hence a wealth of opportunities to start cooperation between university and industry, between industry and administration, etc. At a personal level, you are in contact with other cultures, practices, working methods. You acquire knowledge through working and experienced experts. National international teamwork and practice of technical English enhance your personal development. New generation networks. National Committee of countries like UK, US, Australia, New Zealand, etc. have created a next generation network, NGN, that aims to develop the next generation of power engineering professionals. SIGRE is present in India since 1971. Since its foundation, SIGRE India helps the country to deal with its challenges in the areas of electricity and demonstrates the strength of the Indian power system engineering worldwide. The SIGRE India brings together top experts spread across 16 minor study committees at national level. The dissemination of consolidated knowledge is done through publications and national and international workshops, seminars, symposia, etc. So, get associated with this unique organization and take maximum advantage of this forum for accentuating the knowledge in electric power system.
Thank you. Now, without further delay, may I invite Shri A.K. Dinkarji, Secretary CBIP and SIGRE India, to deliver welcome address. Sir, please.
Hello, am I audible?
Yes, sir.
Okay. I am AK Dinkar, Secretary CBIP and CIGRE India. I have with me my colleague Mr. AK Bhatnagar, Director CIGRE India. I welcome you all to this online tutorial on high voltage on-site testing with partial discharge being organized by CIGRE India under the aegis of CIGRE National Study Committee NSC D1 on materials and emerging test techniques. Ladies and gentlemen, as you are aware, the current pandemic COVID-19 has badly affected the activities and dissemination of knowledge has become a great challenge. In this situation, when option for physical conferencing is limited, CIGRE India, with the guidance and support of CIGRE Study Committee, has planned series of international tutorials to serve the professionals in particular and power sector as a whole. I am glad to share with you the excellent support and help extended to CIGRE India in achieving its objectives of dissemination of knowledge effectively during current pandemic situation by Dr. Ralph as Chairman of CIGRE Study Committee D1 on materials and emerging test techniques and global authority on the subject. We are honored to have him with us today. He has not only agreed to our request to enrich the participants through his tutorial today, but also helping CIGRE India in organizing series of virtual tutorials on the subject of study committee D1 through deputation of the experts from his study committee as presenters. We have in line 3 more tutorials this year on the subject, one in the month of November and 2 in December. I welcome Dr. Ralph and I am grateful to him for his special consideration to our request and his support. We also have with us an eminent professional on the subject, Dr. B.P. Muni, GM, BHEL, who is National Representative in CIGRE Study Committee D1 and is in charge for the activities relating to SC D1 at national level. I welcome you, Dr. Muni. We are regularly getting good support from our members for organization of such important events, and Mr. Sam Gore and Mrs. Alta Nova have supported us for this tutorial. I would like to welcome Mr. Mustafa Baj, Director from Mr. Sam Gore, India, who is with us today for his opening session. I am happy to inform you that we have more than 150 participants from about 30 organizations for the tutorial, and this speaks the success of our efforts. I request you all to please take maximum advantage of this opportunity. With this, I once again welcome you all and also request the participants to join CIGRE as its member and connect with global power system community. Thank you, and over to Dr. Muni for his address.
Respected Secretary CBIP and CIGRE India, Mr. AK Dinkar and AK Bhatnagar, Directors CIGRE India and CBIP, and Dr. Rao.
Sir, your voice is not audible. Can you please, sir?
Yeah, okay. Is it? Hello,
Yes, sir.
is it audible now?
Sir,
Same.
quite audible.
Okay. Uh, as you know, I think now is audible. Same situation.
Audible.
Audible. Okay. Now I am BP Muni, Indian Member of SCD1 Committee. I welcome all of you today's tutorial on high voltage on-site testing with partial discharge measurements. As you know, this CIGRE is one of the main electric body of world international level, and mainly its objective of CIGRE is promotion of technical knowledge, exchange of technical and knowledge, and dissemination of information among experts in the field of electrical energy. The CIGRE Technical Council at the helm of the affair and is supported by 16 study committees spread over throughout the world. In India, and we have a SCD1 committee written by me, and also we have a national committee. Also, we are also looking for the committee members. I request those are interested, give mail to Mr. Viswandat or me regard to become member of the local study committee. And as you know, SIGRE disseminates technical information by two modes. One is publication of technical reports prepared by technical intense working groups, and secondly by organization of technical events such as conferences, symposia, colloquia, and tutorials, etc. We actively promotes the development of skills and knowledge and provide a wide range of opportunities for stakeholders to share knowledge and experience and to collaborate with each other for development of themselves as well as their organizations. And as you know, it is widely accepted that the efficient use of electric energy is at the heart of the sustainable future for our world. And this is a great opportunity for SIGRE members. Today, electric power system has become even more dispersed and at the same time more integrated to provide sustainable, uninterrupted power to the society at optimum cost and reliability. Now, the SCD1 committee has mainly have two objectives. The scope of the committee is covers new and existing materials for electrotechnology, then diagnostic techniques and related knowledge, rules, as well as emerging test techniques with expected impact on the power system and the medium and long term. And our main principal interests are four, basically insulating gases and gaseous insulation systems, liquid and liquid impregnated insulation system, solid materials, high voltage and high current testing and diagnostic. And currently, depending on situation, even like we have a lot of new product methods being developed, like a lot of energy storage system also, and this ever increasing area. So currently we are our actively directed towards characterization of materials and electrical insulation system, study of emerging and diagnosis techniques for HVDC, development of diagnostic tools and related knowledge-based rules, characteristics and test techniques for BESS. Now, as you know, due to the worldwide pandemic situation, we are not able to conduct physical conference or tutorials. We have planned 4 tutorials in this calendar year, and this is the first one, and we have 3 more tutorials in the month of November and December. I request fellow experts to attend the tutorials in large numbers for exchange of knowledge and adoption of best practices in our techniques. And at the end, I request all the members, those are interested, to give their name for become a member of the National Study Committee of for SCD1 committee at local level. And with this, I pass on the mic to Mr. Mustafa Baz, Director Samgar, give the address. Mr. Samgar, can you please take over?
Sure, just give me a moment. Samgor India team welcomes all our dear friends of the electrical fraternity for today's session of online tutorial for on-site high voltage testing and PD measurement. I welcome the eminent speaker, Mr. Ralph Peach, and thank him for his time in sharing his experiences and knowledge with all of us here. Thanks to the CBIP and SIGRE committees for organizing these useful interactions that help all sides to understand the experiences and best practices prevalent across the spectrum of continents. The topic selected for today's session is of vital importance to HV equipment OEMs, installers, and site testing teams who have to qualify an equipment and confirm to the asset owner that he finds it suitable to be used for its entire intended life cycle. The question arising is site testing more important or factory testing? If you're testing at the site, the same thing as it was tested in the factory, it serves no real purpose. But if you've tested parts of the system and assembled them at the site, or if the particular objects are prone to changes or damage during transportation to the site, and there are special know-how and skills involved in installation, then yes, factory testing is important, but site testing is very, very crucial. The second question, what and how do we need to make the test to assure ourselves that we can assure the asset owner? For this reason, we are all online today and to hear Mr. Ralph, and I will leave this topic for him to cover. One of those things that we would be looking to have an insight into from the session by Mr. Ralph is site testing of XLPE cables. The entire cable is tested for its insulation strength at the factory before dispatch. Nobody of us has any doubt regarding the quality of the same. But what does it go through once at the site? End terminations, multiple joints, improper methods of pulling and laying, higher bending radius, etc., etc. Studies of cable failures across the world have shown that most failures occur due to improper jointings and terminations, almost 80 to 90%, and very less due to the quality of cable itself. But what do we do to test it at site? Due to lack of resources, usually it is pushed across to the utility with a 24-hour soak test. Does it really serve the purpose? For a 220 kV cable, the phase to earth voltage is about 127 kV. After charging, it is supposed to operate at this voltage for its lifetime of 25-30 years or more. And we just say it is okay if it passes the test for 24 hours. If that is so, then applying the same argument, all equipments in substations would be qualified to pass if it works for 24 hours without any incidents. Why do we need to test a cable or GIS or transformer at voltages much higher than its operating voltage? It is to observe the insulation under stress and make sure that with the aging and degradation due to temperature, the insulation strength will still last its lifetime. It is to stress the insulation and find out if any underlying fault created during installation has lowered the intended capacity of the object. So while IEC 62060 does allow for a soak test, we still find that in Europe and Middle East and America, customers insist for doing an offline power frequency withstand test along with partial discharge measurements, and then only qualifying the EHV cable. We need to understand why and how it is important for us to interpret the standards in a way that helps us build a more reliable power system network. One another point that I would look to have an insight from today's session is regarding the practicable applicability of SIGRE norms for PD sensitivity test and UHF PD detection in GIS. Is there a way where both tests can be made generic and not specific to calibrators and PD systems used in the factory? Currently, there's insistence to use the same calibrator and same PD system for factory testing and site testing. With multiple locations over the world and multiple site locations across a single country, that is not practically feasible. I would keep my address short so as to use more time hearing Mr. Ralph. I express my gratitude to all of you for listening me through. Have a good and informative time today, and may God keep you all safe and healthy in these trying times. Thank you.
Thank you, sir, for your very informative address. Now we start the tutorial, and I would like to introduce our speaker of this tutorial, Dr. Rolf from Germany, who's the chairman of SIGRE Study Committee D1 on materials and emerging test techniques. So I request Dr. Rolf to kindly start with his presentation now.
Okay, I hope everyone can hear me. So I'd like to welcome you and good afternoon to all of you and all the listeners. And thank you for the introduction. And now I'd like to share my slides with you. And I will start with a optical summary, which was already said. And I was asked, hopefully it works, just a moment. Just to share. No, I guess you can see everything. Is it right? So
not yet, sir.
So it maybe takes some time. No. Can you see it now?
No, no, sir.
Okay, I will try again. It's strange because on my computer it says it's visible.
He's sharing, right? Can you give to him, organizer?
He have full right, sir. He have full right.
I will try it again. We checked it yesterday. Yesterday it was working. But nevertheless, again, it shows on my computer that you can see it. It's
No, sir.
It's strange.
Sir, you just go to share content, right? This is top right corner. Just a square box and with a arrow. Hello.
Okay, I will check again.
Yeah, you can just click on this, then. Hello.
Yep.
Click on this and yes, then you see there is one screen there.
I know. Yeah, I will do it again. Can you see it now, the screen?
Not visible.
Today's session will be of 2 hours, which will include presentation and it will be followed by a Q&A session at the end. It is my humble request to all of you.
So you just press Control Shift and E. All three keys together. Shift, Control Shift and E.
14:35 we will start with the CEO and Director Zen India. Now I would like to give you all a brief introduction of.
Strange. Why?
He is CEO and Director Zen India Private Limited.
Because the computers.
For 24 years.
Try to means just leave the meeting and join again, sir. Then try, sir, if it is possible.
It's a little bit tricky to understand because somebody else is speaking. So because it shows.
Sir, shall we play the presentation from our end, if you allow?
Yes, but it's a PDF file. But it's strange because my computer says that I'm sharing it with you because it's surrounded by a red line, and that means I'm sharing it. So I try it again and close it.
And retry.
So now I try it again, Inhalt, also to submit the content. So I will try this one. But no, it's not working. I see it. Let's try the other one. It's a little bit strange. Why?
Sir, it's visible now. It's visible now.
Now you can see it. Just a moment again. Now it's visible?
Yes.
And which presentation? The presenter or the complete one?
No, not the presentation, sir, but
the presenter.
tab.
Okay, so I change it. It's now possible.
Yes, sir. You can just minimize it, sir, and open the display. Yes, sir. Now it's visible.
Is it now visible?
No, not yet.
It's strange. Okay, I have to duplicate it once again. Sorry. It's a computer. Because I make it this way. Just a moment. Because I guess the beamer is disturbing the reference. Now you should see it.
No, sir, it's stop sharing now.
Now you can see it.
No, it's stopped, sir. We are not able to see your screen now.
Not visible.
Not visible. That's
Just
strange.
2 minutes back, it was visible.
Okay, that's strange. I try again. Sorry for this. Is it now visible?
No.
I switch off the beamer, I guess, because the beamer disturbs, and so I try it again without beamer. And it should work better. And I will share again my screen with you. Can you see it now?
It's not visible.
No, sir.
Not visible.
Is it possible that we share on behalf of you, sir?
Shall we display from here so that you can speak?
Yes, I can understand and see everything and also the video. It's strange that I would make a last check. Once again, can you see this? I guess not.
No, not visible.
I don't know why. Because I can communicate with you, I see you, and the screen says it's shared with you.
There is open share tray. Have you opened the file earlier? Then open the open share tray. Then click particular file.
Yeah, I will. So now make it in a different way as you. Sorry for this. It's strange. So. Is now something visible? I guess
Yes,
not.
Yeah.
it's visible.
It's strange because it's on another screen. I maybe now understand. Okay, now I switch to the presentation. Is it visible?
Yeah, visible.
Okay, sorry for that. So the first, welcome you again. And I have a short part about the benefits of SIGO, which you have already heard. But this is, as I have been informed, that you will get both this short introduction and the presentation, the tutorial itself, as a participant. So what I like to revise again is the future power systems and best use of existing systems. That means hardware and so on. And mostly important is that, which was already presented and said, that the intention is to share the knowledge worldwide. And this is the reason also for today, for the tutorial given by D1 and in my person as the chairman, and Ivanka Höhlein, who is responsible for the tutorials in D1. So what are the benefits if you are, for example, are working in a company? Why should the company send you to SIGO or to be a member? And there's a national, one reason is you get benefits, you have contact like today with other persons worldwide, special experts. And in addition, you get the products of SIGO are shown here. This is a SIGO organization and you have access to the website. And the other thing is the technical brochures, which were mentioned already. Now we have already more than 800. Then the green books. There's just recently published a green book about the future supply systems, and all 16 study committees had contributed to this. So this is very unique and likes to make a forecast for the next 10, 20, 30 years, which is really tricky. And then the secret science and engineering, and of course the lecturer. The other thing is oops, too fast, sorry, is to the different brochures. And as we have heard, there are 16 study committees divided in 4 groups, and D1 is here in the bottom, and it's together with D1.
Sorry to interrupt, sir, but the screen, the slides are not moving.
Okay, which one is, what do you see now?
It's on the first one.
Okay, so that's strange. Okay. Why it doesn't move now? Okay, I will, maybe now it's moving.
Second one.
Okay. And this is the third one?
No, I think.
What is this now? Okay, I will try again. Is it now visible? The second one, products of Seagram. Why doesn't work?
Sir, actually, our team members have shared that presentation from our. So maybe you may continue and.
Yeah, I will try the other one.
Change the slides from here on.
So I guess I will start with the tutorial itself.
Okay.
And I will try to share again.
So you are on third slide, I think, sir.
Pardon?
You are on third slide.
Okay, that's strange. I will close this one, and now that's strange. Why? Because now I'm at the company and I'm in a different network. Yesterday it works perfectly.
So is it possible that I'll share from here? You just instruct me when I have to move for next slides.
Yes, and I will try last try, and then we move as you suggested.
Right.
Last try. Can you see this now?
No, sir.
It's strange. I don't understand why.
I'll share on behalf of you, so you just instruct me.
Yes, yes. So I give the screen free again for you.
This was a tutorial. This presentation is running.
No, it's the same problem.
No. Now it's okay, sir. You see the third slide, sir.
But I don't see it. I see only. I don't see any.
Yeah, you just skip your presentation, close your presentation, and I open from here, sir. You can just instruct me when I have to move for further slides, sir.
But I don't see the slides. I see only all the participants as just names. I don't see anything. So now I'm not seeing the slides.
So is it possible you just leave and join again, sir? Rejoin?
The complete, okay.
Yes, sir.
So your video is not coming. Yeah, we can able to hear you clearly, but your video is not coming.
I'm back now. I can hear you. Again, I see only all the persons with short names like.
Yes, sir. Yes, sir. This is there. Now you try at your end, sir, if it is possible. Then otherwise we will operate from here.
I will try again. Now you can see the slide?
Yes, sir. Yes, sir.
I can see now.
Okay, I'd like to make, and this, oops, again. No,
Yeah, it's
switch.
perfect, sir. Perfect, sir. Perfect.
Visible.
Okay, but okay, perfect. Sorry for that. I didn't know why. Just restarted and it works. Okay. So this you have already seen. And today I have the honor to talk about the results of the working group D133. And the paper was published in 2012, so nearly 8 years ago. Why is it still interesting? And in addition, as you will see later, that over the time, many new technical brochures have published in addition, which supports the results which I like to show you today. And the intention of this working group was to give an overview what we can do to combine AC voltage test on-site or lightning impulse test together with diagnostic tools and especially partial discharge. And this is already what you have seen, I guess, the main key points for today. First part is I try to use the laser pointer. And if you don't see anything, please let me know. So that you have different possibilities to produce if you switch off the equipment to apply AC voltage, damped AC voltage, VLF, and so on. I will come to that briefly later. And possibilities how to improve the PD sensitivity and measurement on site, because on site you have much more disturbances than in a factory in the test hall. And then I will concentrate on PD measurement, and I was asked also to briefly mention what are PDs, what partial discharge are. The so-called conventional PD measurement I will explain, and then the other possibilities which were already mentioned, like UHF, ultra-high frequency, acoustic, optical, and so on. And then this technical brochure has collected at that time several examples, and the focus was GIS, so 2 examples were given. Cable systems, 5 examples are given. I will only show 1 or 2 each, and rotating machines, and of course power transformers. And this is how the looks like. And yeah, why testing? In the introduction of my former speakers, it was also mentioned, we normally do the development tests and type tests, and of course the routine tests, which are part of the quality tests. And then the equipment is delivered on site, and maybe due to transportation or because equipment has to be erected on site, not everything can produce or transport it as one piece. So there are possibilities that things have gone worse or were damaged. And very important from the physical background, some components have not seen voltage stress because they can also only stressed as a combination. For example, the joints for the cable, which are done on site, especially for ultra high voltage cable. And then the other thing is diagnostic and maintenance and repair. After some years, you have to watch and to see what is going on, just because the time has passed or there are some indicators that you have to go on site. So there are 2 main differences. One is commissioning, which is very important to distinguish. The other one is diagnostic. Why the difference? Because if you make commissioning tests, special voltage shapes are allowed. And for diagnostics, you can nearly do what you want, so to say. But of course, you have to talk with the end user if this is okay or not. And I will explain, and this was the intention of this technical brochure, to clarify this. And as I said, I was asked to say something briefly in addition. This is not part of the technical brochure, but part of SIGRE is about partial discharges. And PD is a localized electrical discharge, and as I said, suitable for diagnostics. And as mentioned, there are different standards. In this case, the standard for the measurement of partial discharges, and their so-called apparent charge is defined. And the apparent charge is a charge which, if you inject it into the equipment, and then the PD measuring system can pick it up as a current and then this current integrated is the so-called apparent charge. And it is important to distinguish that this is not the real charge at the location of the PD. For example, if it's inside the transformer and you pick the signal at the bushing, there's a big difference between this, and this has to be kept in mind. And of course, you need a local electric field, and then a defect. In this case, for example, is a gas-insulated part. Then you have a discharge, and in a homogeneous field, it will directly break down and so on. If it's inhomogeneous, then this can serve as a diagnostic, and this is very often used. And this is, for example, some pictures, double exposure. That's the reason that you can see it like here. So you have here high voltage applied, and this aluminum tube, which has some scratches, and you see the localized PD. They are in the region of 30-40 picocoulomb. And if the test lab is dark and all lights switch off and your eye is adapted, you will see it like that. The so-called basic circuit, according to the standard, is with a coupling capacitor, which is connected in parallel to the test object, like the transformer or GIS. And then you can evaluate the current which is flowing here to the test object and the coupling capacitor. And then this is analyzed at the PD amplitude. Important is, and this is what can be used on site, there are optical effects which we have just seen. There are also heat over the time, pressure waves like sound, acoustic in a transformer or GIS, or if you're close to a bushing, then you can hear it. Chemical effects like the production of hydrogen or CO2 in a transformer if the oil is damaged over the time, high frequency waves, and so on. So you can pick them up with electrical, and this is normally covered with this standard, and then the so-called non-conventional methods, which like the high frequency measured and the ultra high frequency, they are electrical. And of course, the non-electrical ones, these are chemical, optical, and so on. Now, coming back to my presentation, which is part of the technical brochure. And as I mentioned, first we have to see what kind of high voltage source can we deliver on site. And there you have to distinguish between the so-called Western testing, normally 1 minute, and with an increased voltage level. This is done during type testing, routine tests, and so on. These values are described by the relevant standard for cable, for GIS compartment, and so on. And this is normally required, or at least said it's a complementary addition is PD measurement, and this the aim is to assure the quality which I mentioned. Sometimes it's destructive. For example, if you have a transformer and you apply lightning impulse, which is part, but this is not the intention of today. I will concentrate on AC voltage tests. And then on site, if it's aged, for example, after 5 years, or you make just to see if it's has aged, if something's going wrong, then you like to see, okay, what is going on site, like gas and oil analysis, or I'm looking for the tongue delta, dielectric measurements, power loss measurements, and the PD. And then the tricky parts come, what is really going on, what can I do? And mostly there should be non-destructive, because all the systems should be still in operation if the values are okay. Here now is different examples which were covered by this technical brochure. On this side, you see a GIS with bushings. There's a resonant test system outside. And so one phase is applied with voltage, 400 kV GIS. Another B is a gas insulated GIS inside the substation with a so-called resonant test system. I will shortly explain later. And the other one is here shown, is with damped AC voltage. How it works, I will also explain. And there's another example for testing a power transformer, again with a so-called static frequency converter. The technical brochure gives also some hints just to prepare if you're going on site, what have you to think about what kind of test object do you have. Is it a combination of different equipment like transformer, GIS, and cable? So you have to be careful choosing the right voltage and also voltage shape, and about security aspects and so on, and which kind of equipment should I take with me, and so on. This is described in a short way like a checklist. I will show just briefly, and if you have the technical brochure, you can look at it more closely. Stationary, this is normally known for all who have experience with high voltage testing, commissioning, factory tests, and so on. And mobile, there's another standard which defines the wave shapes and the tolerances which are allowed, and normally they're a little bit higher than if you are inside the factory. And of course, the equipment has to be suitable for transportation. Suitable means from the size point of view, weight point of view, accessibility of the roads to the on-site and so on. And it must be very robust because there's not a smooth highway to every place. Now, this is a very complex slide, and I guess from my point of view, the central part of this technical brochure. And now I like to try to explain what you really see here. On the top, you see the equipment to be tested, like cables, different types, oil paper, medium voltage and high voltage extruded ones, the GIS, GL, gas insulated line, instrument transformers, power transformers, rotating machines, and arresters. The brochure concentrates on rotating machines, power transformers, GIS, and cables. And now here you see W means withstand voltage, 60 seconds with AC, for example, depending on the equipment. PD is a PD measurement. DM means diagnostic measurements like power loss or tank delta, but no withstand tests. That means not higher voltage and not for 1 minute. And now you can see, and these abbreviations standing for frequency resonant test system and transformer, and you will see it on the next slide. Now it's important to have a first view. For example, the very low frequency, 0.1 Hertz sine wave, it's allowed for oil paper cables, medium voltage as a withstand test, and also for medium voltage up to 31 or 32 kilovolt. And of course, a diagnostic method and with PD. Diagnostic means after the system is in operation and you like to have maintenance and so on. And it's also used and defined in the standard and accepted for rotating machines. If you go to higher voltage levels like high voltage cables and GIS, you see that again for the medium voltage cable, it's allowed everything, PD, diagnostic and monitoring, and all AC independent how it's produced, 50 Hertz or 60 Hertz, or slightly between 20 and 300 Hertz for the resonant frequencies. And as I said, this is defined by this 660-3. It allows other frequencies. And so it's allowed for withstand test and PD. And this is for the power equipment in operation. The damped AC, this is a damped AC voltage. We will see later how it looks like. Again, it's for monitoring and diagnostics, but not for a withstand voltage because it's not a continuous sine wave. And so the equipment is not stressed as it should be. And then there's some other lightning, oscillating and switching, which is not part today of my presentation. As I said, how are the circuits? This is a typical normal circuit for transformer testing, compensated of course, but you need, for example, if it's a big cable or long cable, you need a lot of energy or power up to 10, up to 50 MVA. So you really need very high powerful power supply and transformer, and it's not always suitable. And that was the reason to invent 30 years ago or something, the 0.1 very low frequency resonant test system. The other one is the tuned resonant test system. And here the very simple equation, the frequency, for example, for the after installation test, you have to have 50 or 60 hertz due to the fact that the cable or the GS capacitance will change. And if you had or have a fixed inductance, then of course the frequency will change. And this is not allowed. So what you have to do is to have one possibility is to change the inductance. And this is shown here, where you can change the inductance. That means depending on the frequency, on the capacitance of the cable, the frequency can be adjusted to 50 hertz. Over the years, last 30 years, and starting with GS and made my own experience testing on site with variable frequencies, and it was allowed and technical feasible, not only 0.1 hertz, but now with 30 hertz or 20 hertz or 50 hertz. The tricky part is now with power electronics, with a frequency converter. Now you can adapt because the inductance is now fixed, the capacitance, but the capacitance can change. The GS has different sizes on the cables, and that means you have to adapt the frequency in the allowed to the standards. General one, and also for cable and GS, they have defined the frequency range from 20 to 300 hertz. So you have to change the frequency, and the big advantage is that you will reduce massively the power of the in-feed you have to apply. This is shown in this diagram. And the other thing is the so-called power factor. That means the test power and the supply. That means if, for example, you have 100, that means not that you break the energy law of conservation. It means that you have, after 100 oscillations, all the energy is now in the cable, and you have just only to compensate the active power in the resistance of the cable and the supply, and that means this test equipment very powerful. And there's some other things, weight, and so on and so on. The other technology and AC DAC, and this means that the test object, which is a cable, for example, a capacitive, like shown here. Now my pointer is making strange things, but nevertheless, so the cable is charged by DC voltage, which is shown on the left-hand side, and it will take some time depending on the cable length or the capacitance of the cable, which is shown here on the bottom in microfarad, and then you need some time, could be several seconds or several minutes. For medium voltage, it's okay to stress the cable with DC, and then you short circuit the cable via the inductor to ground, and then in combination with the inductor and the capacitance, this circuit starts to oscillate and gives the stemmed sinusoidal AC voltage shape. The other possibility, which I mentioned briefly, is I don't like to mention the technology. This is one possibility. There are different ones, but more important is there are two ways to produce a 0.1 hertz. This is allowed normally in Europe, some other country worldwide, and in US even 0.01 hertz. And the main stress is that you have sinusoidal, but very less polarity reversals, which are very important for the PD activity. And the other one, which is also allowed, is the rectangular wave shape, like here. And again, you have the same number of polarity reversals, and the steepness is a bit higher. This has also an influence on the PD activity. This is very important. And which you might see here, I don't like to go into the physical details, and this was not the intention of the brochure. So the upper pattern shows the partial discharge pattern. It's collected over time. So every dot represents one single discharge, which is shown in relative to the applied phase, in this case 50 hertz, on the bottom at 0.1 hertz. So one oscillation is 10 seconds, and here one oscillation is in 20 milliseconds. And due to the polarity reversals, which I mentioned, you have much more PD pulses than in 0.1. And now you can recognize, okay, it looks quite similar, but it's not similar. And even, for example, this defects now, or whatever it is, could be artificial, could be from the surrounding. So you see, it's very tricky, and only experts who know that technology, especially the object which you test, you have to know what you're testing and also how it's built and designed, that you can make an analysis that this is harmful or not. And this is also a typical pattern figure shown in this technical brochure. The high voltage component, the 3-1, is it new? And service age new, if it's for the factory, then you can make this measurements in frequency or time domain. That means as a typical pulse, and look at the apparent charge. And the so-called non-conventional methods, they use electromagnetic detection, but at higher frequencies, acoustical one or optical. For example, if you have an air-insulated substation and some circuit breaker produces PD, then you can look at the optical appearance of that device, or you have to make a chemical analysis, mostly in combination, like if you have a transformer, you make a gas and oil analysis. And here are the highlight of the electromagnetic PD detection at higher frequencies. Oh, sorry. For cables, high frequency means more than 50 Hertz, several kilohertz. Very high frequency means in this context several 10 of megahertz. And ultra high frequency is now more and more applied to transformers. It was started 30 years ago with GIS, and also these frequency ranges are for generators. And here it's shown how the signal passes, and the signal is electrically handled, that you can later on see on the screen what is going on. And you see there's a lot of signals on the signal is done, and you have to be careful to really see and say what is going on the real test object. And very important is that in this frequency ranges, there are different techniques available. So you can make a so-called zero span, like listening to the radio, PD music. We have defined this internally several decades ago, or make full spectra. And then you down converted it to a PD pattern, and then again you correlate it with a sine wave and to look where the PD activity is, the sign, the position, in respect to the amplitude, the zero crossing, and so on, gives a very important hint what kind of defect you have. And for the ultra high frequency, it's not calibratable. That means that the signal which you see does not represent the apparent charge. It's quantified, repeatable, and so on, but it cannot be just said that this signal is the apparent charge. But there's a so-called performance check, and this is described in these technical brochures, which I just mentioned, which were published later on, like in this year, 2016, and there's a joint working group, which I've forgotten to mention, that the different study committees, like D1, which I'm part of, and A2 transformers are working close together. And so they're making now a joint working group about how to test transformers after repair or maintenance on site. And some part is as a voltage test, and some other parts are non-high voltage tests, and this is the reason that A2 is participating. And then there's a sensitivity check, and it's described here just briefly how to do. And as I said, this technical brochure gives some hints how to prepare, and the difficulty if you make a PD measurement, you see on the screen lots of signals, dots, like each dot, if it's a partial discharge pattern, represents a signal. But the difficulty is it is really a partial discharge in its sense. The next question is this harmful? That means you have to know what kind of equipment you are investigating. You have to know if it's a special transformer type, how the transformer is built, that you can tell, okay, it's maybe on the low voltage part, on the high voltage part. The pattern itself, it's very tricky, and in only very seldom cases, the pattern itself can tell you, oh, it's really harmful or not. And then periodicity of the PD signal is very important. And is a radio frequency disturbance like radio or TV station close to, if you have bushings connected to the transformer or to the GIS, then this is a typical source. Or if you have an air insulated substation close to the GIS substation and it's rainy conditions, then you could have a very high noise. And that was the real intention, to go to higher frequencies, because then it's much easier to distinguish between these noises which coming from broadcasting TV stations and so on. That just briefly mentioned, and there are references how to do this, and this again not part of this brochure. It gives references where this is described in detail, like window gating and low voltage and high voltage filter. There are some possibilities that even under noisy conditions that you can achieve a good PD signal. And if you have PD signal and you see now, let's concentrate on the right side. It seems to be very easy. First part is you detect PD. That means acoustically with a coupling capacitor or the Uhf technology or with the acoustic method. Then the PD identification. Identification means, is it from a corona shield? Is it a free moving particle? Or is it inside a transformer on the high low voltage part? Or is it really PD from a joint? And if it's polyethylene, then normally it's really dangerous. And if you have done this, then it is where it's localized. In a transformer, it's easy to say, so to say, it's inside the transformer, just open it, it's not really just open it, but it's much more easier. But if you have a 20 kilometer long cable, then the localization is a very tricky part. This can be done, it's not the only one, by time domain reflectometry. That means you just look at the echo, which is produced by the pulse and reflecting inside the cable back and forth for several times. But even if you have this and you have the PD signal, the pattern, and now you can see how complicated the PD evaluation is. And for example, the different components produce different PD signals and have different PD generation, like cavities or air gaps or corona, like in a GIS or a substation or surface discharges. And then the different objects, like, as I said, the cable. If the cable is very long, then the damping is quite high. If you have a transformer, then you have a lot of cross-linking, for example, if it's a three-phase system. And then the question is, what quantity can analyze, like the magnitude, the phase, which I said is very important, the intensity, the number of pulses per second per period. If you have just one pulse per hour, like under DC case, which is not part of today, then it's very tricky to say what is going on. The PD quantity itself can be analyzed. And then if you even have all this information, then still you need experienced person who can analyze. Up to now, there's no expert system by software, only with very few and clear situations. It can give hints, in some cases quite good, but not under every cases. Why? Because the equipment is every time different, and all the propagation effects, crosstalking, makes the thing much more complicated. That is one reason that this does not work perfectly on an automatic way. Then, as I said, again, some advices, what you have to think about before you go on site. Very important, and it seems trivial, but it's again like a checklist. The ratings is important. Is it a new cable? Is it what kind of equipment and power do I have? What is the power supply on site? Do I have to use a diesel generator, and so on and so on? And the next question is, what kind of equipment is it? Is it a transformer, a cable, medium voltage cable, or high voltage? And this defines the test voltage shape and the frequency, which is allowed, like testing at 30 Hertz. And the other thing is the supply. Where is the equipment? Is it located in a cavern, inside the mountain? Is it somewhere in the desert or in high mountains? And very important for the safety issues, the grounding requirements, also for the noise suppression, and mainly for the safety of the person and of the equipment, of course. And then some possibilities of the power supply, the filtering of the power supply, the grounding system. Is it has the grounding system a lot of noise on it? Then you have to improve the system, and so on and so on. Now, as I mentioned, after these general issues, there are some examples given for the equipment like cable, GIS, power transformers, and rotating machine. Now I like to speak about those examples. And here, starting first with the GIS, gas and lighted substations. And then first you have to clarify what is on-site possible. I have done it with all of these things personally on a GIS, so with a coupling capacitor according to this conventional method. And then the other is the UHF technology, ultra high frequency. It means you go up to 1 gigahertz or even higher, narrowband or wideband. The other one is acoustic. It's very precise. Precise means half a meter or even better, but this is very time consuming. And the best way is to do everything. And this can be done and should be if it's a very important substation. I will on the next slide you see how these can the best combination. Again, the required details of test object. It's very important, again, for the power you need. That means for the test source, you have to bring on site how to connect or switch the different substations, single phase, 3-phase. If it's a real big one like E-Type 2, then it's very tricky to measure it with a very simple test system. You have to disconnect some of the base and so on and so on. And you have to get information what you are testing. It's very, very important. So try to get the files about those equipment you have like to test. Had some outages, were some parts repaired and so on, or ask those who have known this. Now, GIS and Gil testing again, there are typical defects, which can be like sharp protrusion, particle on spacers, and so on. High AC voltage means this is not normal operating voltage, this is higher voltage on site. And as you can recognize due to the physical behavior, that the plus means it's good detectable by breakdown or PD, in this case by breakdown. And then the other thing is, as we are talking today, is with partial discharge. Low AC means like monitoring system, low means under operating stress. So this can be identified quite easily. And for commissioning and then high AC voltage test with PD, then you can even detect particles on the live parts. But you see there's still some which are not possible, again, to physical reasons. And the best way is to combine it with lightning impulse, because lightning impulse, oscillating lightning impulse, you can even detect the very sharp protrusions, and this is the best combination. Of course, this is very time consuming. You have accessibility and you have to bring AC source and lightning impulse generator. As I mentioned, this is only important for suitable for a very important substation. UHF sensor looks like that. I don't like to go into details. You have to get access to it. In some cases, it's already installed. In some cases, you can use windows, which are normally available at circuit breakers or earthing or switching compartments, and then you can pick up the signals from the outside through the window. And this is a typical way how to proceed. There's a so-called preconditioning test. Depends on, it's not, sorry, clearly defined, and then you make the Western test for 1 minute, and then you make the PD pattern. Again, the phase correlation in each single pulse is 1 PD. In that case, it was published as a moving particle, and which was found in one part of this compartment. Now I like to come to the cable, which was mentioned in the introduction. So this brochure shows 5 examples, different wave shapes, or voltage sources for medium voltage, lower cables and high voltage cables. With a conventional one, with the resonant test frequency, it's damped AC for diagnostic PD measurement technique. And then for extruded extra high voltage cable with a resonant test system, and the very low frequency, which is allowed for commissioning as a withstand test, and of course for all PD diagnostic techniques. And again, an example is shown in this brochure about PD with UHF technology as special cable accessories, mainly joints. So I will show example 1 and example 2. Example 1, on the left-hand side, you see the different PD defects. I don't like to go into this interpretation. This is shown in this brochure. I like to show the tricky point on site. In this case, I choose this pattern picture because it's very tricky to get access to the cable joint in that part. And then you have an overhead line which is going into the cable, and you can see that and estimate that you can maybe pick up a lot of noises, and even the connection can produce PD corona and so on. So this is experience how to connect, and some cases there are physical large distances to cover. And so it's sometimes really tricky, and you need some good ideas to handle this. And some other examples are shown in this technical brochure too. The other example is test as a diagnostic tool is damped AC voltage. As I said, it's a damped AC voltage. One disadvantage is that the amplitude is decreasing. And normally you have to apply with higher voltage stress, and that means that you can detect during the first oscillations PD. So on the base, you see the PD amplitude, and here another defect. And on the right-hand side, you see a cable, and what is shown here is the cable length. So this is 800 meter, and at one point 100 something like on the cable, and you see after each pulse, so these are the PD detected here, and several damped voltage wave shapes were applied. And so you can see, okay, what is here? And if you know the plan of the cable, this is, as I said, you have to know what you are testing. Maybe there's a joint, then you know, okay, this is a fault to your cable joint, you have to look there. Or if nothing is there, maybe then the cable has something there, and you have to make a closer look at that point. The other example which is shown are rotating machines. Again, 3 examples are shown. Important is visual inspection as every time, insulation resistance in addition, and the power loss factor or dissipation factor, the capacitance as function of test voltage and frequency. And in this case, you can test with different sources and with a conventional PD measurement test I would like to show. Next slide. Here you can see a rotating machine. This is inside a cavern. It's a water power station, hydropower station, and this is a test device with a test system inside, and it was connected to the machine to test. And the intention was over the time and the test voltage, if the losses are increases, that means you have ohmic losses somewhere due to PD activity or whatever. In this case, everything seems to be fine. And normally you do this test over time. Let's say you have done this test 2 years ago, and now you performed this test yesterday, and now maybe last year, 2 years ago, it looks like that, and yesterday it looks like that. That means, okay, something has to be there, and then you need further investigation of this special machine. So then one important device in the distribution and transmission systems is called the power transformer, because if this fails, because it's like the heart, normally you have different transmission lines, you can switch to another, but normally you don't have so much transformers, then you really have a big issue there if the power transformer fails. And here again, some new working group which deals was formed 1 or 2 years ago in with A2 about commissioning after on-site repair and so on. Typical values which you check, and those who are familiar with transformers know it much better than myself. It's insulation resistant, winding resistant, and so on. And of course, also the PD activity of the transformer. And here again, you see also the where is it? No, gas and oil analysis is not mentioned. As I said, we concentrate on electrical systems. And the 3 examples are given in this technical brochure. And I will concentrate on this one. Frequency converter. This is a special technology to produce a nearly perfect sine wave. The Q factor, the harmonic disturbance is below 5% because it's really a perfect sine wave. And the transformer was measured with a conventional, or the PD activity was with a conventional PD measurement. That means a coupling capacitor was connected to the transformer and to see what is going on. And here you see it's the on-site test. This is the device where the power electronics frequency converter is inside. In this case, so-called applied voltage test was done. Applied means really high voltage was applied to the high voltage bushing side of the transformer. So in this case, it was with a resonant frequency, and could be maybe also 50 Hertz, I'm not quite sure. And here you see the coupling capacitor, as I said, was done with a conventional method. The other situation was induced voltage. So we use the low voltage part and feed it with a power source, and then the transformer is stressed, not perfectly the same way as it really on with a high voltage. Inside there's slight differences, but nevertheless, this gives a lot of information about the behavior of this transformer after a repair. For example, if the bushings had some problem and was exchanged, then you will definitely see what is going on, even if you don't have the possibility to do it like this with the applied voltage test. So in this case, both things were possible. Okay, this was nearly the end of my presentation, and the technical brochure, as I mentioned, has 128 references, and this intention was just to give or to say that high voltage test alone is not very successful, and you can combine it very good with partial discharge, even if the voltage stress or the amplitude is like the operation voltage. Nevertheless, you have different chances to look at the PD activity, and this is mentioned in this. And in addition, over the years, there were some additional technical brochures which I like to mention, is testing of long submarine cables. It was published in the same year, and 1 year later, there's a technical brochure again about PD analysis and risk assessment on GIS. So the different defects are described there, and the UHF PD measurement technique again in GIS. And here the sensitivity verification, which I just briefly mentioned, is applied in detail. And then there's a very important guideline. I guess this is also very important for you who have the task or will have the task in future to perform PD measurement on site with the conventional and the unconventional method, and all the unconventional like acoustic, thermal method, if, for example, the bushing has a high temperature and so on. This is described in a very detailed way there, and it was published in 2016. And a very good paper is all technical brochures, partial discharge and transformers, was published nearly 3 years ago. And very recently, also a good technical brochure about testing high voltage and extra high voltage cable systems with in combination with high voltage and partial discharge. So this is exactly what was mentioned in the introduction by some of my former speakers. And very low frequency is mentioned in this technical brochure, finished also 2 years ago, and some other joint working groups, one working groups are still running. And I guess was also important results for you who are all interested in the different kind of equipments. So this I gave in addition to the references there, because on this, to make a summary, this is one reason that Switchgear could be very helpful, because where's the big difference between IC and Switchgear? Switchgear is based on technical aspects. That means not standards, which are some cases very difficult to make a compromise, could be a political. Not political means in the sense of companies and countries, different standards, general ones, and so on. And Switchgear gives recommendations, no standards, but on a real technical issue. And that's the reason that, like in my case, that companies support, in my case, to go there to get change and exchange the knowledge in these working groups or at the symposia or colloquias. And yeah, that's very big advantage. And independent of the concrete technical brochure, which I mentioned today, you can find a lot additional information to the same topic and to find information which help you to improve or find the defect in your equipment. Okay, that's what's for today. Thank you for your kind attention, and I hope everybody could understand me acoustically and follow my slides. So now you have the chance to ask speak or in written way questions.
Dr. Ralph, thank you very much for your presentation. And now, can you see the questions in chat box, or shall I read them?
Just a moment. I just open it. Now I see the chat box. Yes.
Yeah, queries are there. And the first query is from Soumya Raj at 3:43 p.m. You can start answering them, these questions.
Can you maybe it's better that you show it on the screen, because the time I have my local time and you have your local time, so it's tricky to.
Yeah, right. I'm just reading the questions. Okay. Yep. The question from Soumya Roy, and what are the current techniques used to localize underground cable fault? How to detect any internal partial discharge occurring inside cable insulation or from any joint? This is with reference to 6 to 11 kV, 33 kV.
Again, there was just recently published a brochure about localizing PD in cables. Maybe I can send this later, and it depends on what kind of cable. Is it inside a city? Then normally you can use acoustic methods if you still have the voltage applied on, because it makes noisy discharge. Or if it's a crosslink box, then maybe there you have access, or you have already built in high current, high frequency current transformers where you can pick up the signal. So it depends on really which kind of cable you have and where you have access. And I like to refer to this technical brochure of B1. Was recently 1 or 2 years published, and gives much more very good details how to pinpoint the defect. You need different techniques. It's not only one possible.
Yeah, next question is from Ritu Raj. Why any electrical distance test is done for 60 seconds always? What is the theory behind this?
Very good question. The 60 seconds, let's, yeah.
60 seconds, yeah.
Yeah, 60 seconds. This is again convention. And your point is right, because it depends on the defect. For example, if you go for air corona, then if you have an air insulated substation and you have just corona, then it's not harmful. You have only losses, that if you have corona and it's visible. But if you have a cable insulation like polyethylene and you have PD even over 60 seconds, then it's only a question of time that the cable will die after 1 hour. So this is a kind of compromise, and that it's 60 seconds. And this is in the standard, and you should not overstress the cable. I had got the only experience we made. Unfortunately, the timing was wrong, 70 seconds, and the equipment failed. And now you can imagine what kind of discussion we had. And so this is a standard, and the physical reason behind is it's more compromise.
The next question is from Mrityunjay Kumar from BHCL. PD patterns help us determine the type of defects like floating particles, defective insulator, etc. In GIS, does for the same defect, conventional UHF and acoustic PD measurement method will give the same result, same type of PD pattern?
Yes. For GS, I'm now more familiar because I've done it for several years and still do it today in some cases. So the conventional method and the UHF method produce, if they pick up the same PD impulse independent of the amplitude, they produce the same pattern. And also the correlation to the wave shape, also to the sine wave. The acoustic is more tricky because this normally you make it just to pinpoint where is the defect. So normally you can also look with the acoustic and make a PD pattern with the acoustics, and you will achieve the same PD pattern. That's right. I have to stress this: if you have only one PD effect at the same time, you have different ones, then it's more tricky. But you can use all of them. The sensitivity is a little bit different, but the electrical patterns are the same, UHF and conventional.
Now, next question is from Mr. Anuradha Singh. The question is the connection of the PD instrument to the PTR, overhead cables and underground cables required.
I didn't get the point. What was the question?
The question is connection of the PD instrument to the PTR.
Yes.
Overhead cables and underground cables is required. That means he is asking that connections to this instrument, how they have to connect with equipment. Connection of PD instrument to PTR, overhead cables and underground cables. Maybe you can throw some light on that.
It's very important because in some cases the test frequency is different for the instrument transformers and for the cable and also the amplitudes. I know it definitely for a cable and a GIS, and also for the instrument transformers in the GIS, that you have to be very careful to apply higher voltage levels. And if it's connected, the GIS, the instrument transformer operating, normally you have to go higher frequencies, normally more than 100 Hertz, or you have disconnect the instruments transformers. So I don't know where's air insulated instruments transformers. So you have to look at the technical description of this instrument transformer, if it's allowed to test with the same voltage like the GIS and with the same frequency. You have to look at the spec.
Okay, thank you. Next question is from Mr. Rituraj. If PD found in the center of insulation system, then what should be done to improve the life of insulation in terms of voltage, distance, and time?
In which first question is in which kind of material?
If PD is found in the center of the insulation system, then what should be done to improve the life of insulation in terms of voltage, distance, and time?
Again, which insulation? Is it liquid or is it solid dielectric, oil paper, or polyethylene?
Not specified anything.
If it's if it's polyethylene, then you can't do anything. You have to replace this part if you can pinpoint. In a transformer, I'm not an expert. That depends on exactly where inside the transformer, if it's possible. In some cases with acoustic and in combination with electrical measurements, you can pinpoint, let's say, within half a meter. And if you know the design of the transformer, you can tell, okay, it's dangerous at that part. Dangerous means I have to disconnect it and to repair, or we have to make some further investigations like gas and oil analysis and to say, okay, maybe we can run it for half a year or 1 month or so on, and in that time you can think what to do. So it's not easy to answer. Depends on the equipment and the insulation material and the design.
Yeah. Now the next question is from Anuradha Singh. What is testing details in offline online mode is also required? That is statement. Testing details in offline and online required. That is the statement. You can elaborate a little on this.
If it's after installation test, then of course it's offline. If you do it for online, then you have two, so to say, disadvantages. So first one, you have the same frequency, okay? And unfortunately, you cannot change the voltage. What does it mean? If you change the voltage, for example, if you're offline, you have the inception and extinction voltage of the PD, and this gives you a very helpful information what kind of defect you have. The other thing is if you have frequency resonant test system and you operate at 30 Hertz, for example, and the power frequency, for example, in Europe, it's 50 Hertz, then you definitely can distinguish external noise and real PD very easily because the phase correlation, the frequency repetition rate is correlated to the external frequency. And that's one of the big disadvantages if you have just the power supply and the amplitude of 50 Hertz on site. That's my answer.
Okay, thank you. Thank you. Next question is from Ashish Akbari from ERDA. What is the PD pattern in STATCOM? Is a fax device measurement? Is it applicable? Maybe some has some doubt. So is the PD pattern applicable with STATCOM equipment?
Actually, I have no direct experience with that, but the resonance test system, which I mentioned, they are normally with so-called frequency converters, and also we have a frequency converters known which are used for power transformers, and they operate at several 10 kilohertz. And so you can, by a perfect design, you can get rid of the emitted by radio emission. Of course, you need filters, which on the conducted part to suppress these high frequency components. So I don't know. I know that there are filters before the power is going into the cable or HVDC line. So I don't have the experience, but filtering is necessary.
Okay. Thank you. The next question is from Nandish Kumar. His question is, what is your experience on air insulator switchgear online PD measurement?
By myself, I have no experience on air insulated substation. Sorry about that. I can't tell. Maybe somebody of the participants. I have no experience with air insulated monitoring of PD. But I only know that people are going like the utilities by time after time by airplane to looking with a UV camera, a thermal camera, to looking at the suspension lines if there's PD activity or not. But I have no with continuous monitoring. I can't tell, unfortunately.
Okay, thank you. Next question is from Mr. Mustaf Baz from Samgaur, India. And this is with reference to IEC 62060 for SBX XLP cable. Testing provides option for 24-hour soak test. Can you please clarify, going by your experience, if that should be the way to go, or is it important to stress the insulation at higher voltage for installation testing like 1.4 into V0 nominal voltage?
You definitely, maybe I'm just looking on my screen, just a moment. There was a very important publication I'm looking here when I'm speaking. I hope to find it. That the 24-hour test will not show every time every defect, because it takes time to start the defect. That means the amplitude and the time duration. It's the same question, so to say, why 60 seconds at higher rated voltage? And there was a very good publication, which I mentioned, which is also in the references. I'm just looking for that. Just a moment. It takes some seconds and I will. So there's a good explanation because it has to do with statistics. If you're, for example, just test with U naught as a normal stress, you will not detect the defect in a given time. That means definitely not 24 hours, only if it's a very, very harmful or dangerous defect. The other ones need time and definitely more than 24 hours. And the higher stressed voltage at 1.45 or even 2 times 2 depends on the voltage, rated voltage. Then you need, and this is again a convention 1 hour, and then you can pick up at least 80 or 90% of the possible defects which were introduced during installation or in the cable joints, whatever. That is a question of statistics plus amplitude. So 24 hours is definitely not enough. Only in the case if you have no test equipment. But that does not mean that you can be sure if you do this test. Be careful.
Thank you. The next point is from Abid Sekar. Could you please share the entire PPT? We will share it in due course with all participants. Okay. Next is from Rasmi Getco. How to decide UHF sensors location in GIS for measurement of complete GIS?
So the question is how far is the difference between each sensor, right?
How to decide UHF sensor locations in GIS for measurement of complete GIS?
Again, there are one slide and one technical brochure which I mentioned in the references describes where you have to place the sensors in the GIS design. There's a secret brochure which gives at least hints what to do.
Okay. The next
so
question.
If maybe he can send by email his question and I can look for the reference and send it to him. There in detail it's described where to locate the UHF sensor.
These sensors, yeah, correct. Okay. We'll ask it to send to you. Okay. Next is from Kausik Madhav. Is it suggested to perform DAC test to find PD in underground cable of 11, 33, 63 kV and above? Kindly explain. Is it suggested to perform DAC test to find PD in underground cables of 11, 33 and 63 kV and above? Please kindly explain. That's it.
I didn't get really the point due to acoustics. What is the difference? Which kind of test?
Is it suggested to perform DAC test? DAC, D for Delhi AC, DAC test. To find PD in underground cables.
What does the DAC means? Thermal? No. I didn't.
Nikki, can you elaborate and put your chat box?
Damped AC, DAC.
DAC.
Damped AC, no? Yeah. For medium voltage is allowed, for high voltage not. It's due to the physical reason that the PD activity, this is valid for commissioning tests, is not for diagnostics. Because there are, as I said, you need two things. One is electrical field and you need charges. And if you use it for diagnostics, then it's allowed because you already have charges. And if you disconnect from the rated voltage and use the damped AC, then you can start the PD activity. This is physical reasons which I don't like to go into detail. Again, this is described in the technical brochures, which I also have given for you in the references, in the additional ones. So there you will find the physical explanations. Sorry, because otherwise I'm maybe, yeah, it's by word to describe. It's much not so easy.
Next question from Mrityunjay Kumar. Are external type USF PD sensors provide enough sensitivity for good online continuous monitoring of PD at any site at a site in GIS? The question: are external type USF PD sensors provide enough sensitivity for good online continuous monitoring of PD at site in GIS? Please share your experience on using external type USF sensor in comparison to internal type USF sensors for GIS applications.
There's one simple answer. The first one is, of course, is the internal sensor much more sensitive than the external one. Why? Because you can imagine that the UHF sensor, it's a plate and has a capacitive coupling to the inner conductor. It's not correct physically, but you can imagine. And so the distance is higher if you have an external sensor which is applied on a window. And that means the sensitivity is lower. That means if the defect is much farther away from the window, then definitely you will not observe it with the external sensor. There's one external sensor which you can use, and this is connected to the spacer itself. In some cases, there's an external sensor built in the spacer itself. So again, it depends on which kind of UHF sensor, the geometry, the design of the GIS, the position of the sensor, and so on. But definitely it would be much better. I don't know if it's 50% better or even more. I can't tell because it depends on the GIS from GIS.
Thank you. The next question is from Lokesh Kumar Sharma. Presently for GIS, we are using resonant frequency method for SB and PD measurement. What other methods can be used to carry out both SB and PD measurements?
I didn't get the last question. What can be?
Yeah. Presently you're using resonant frequency method for SB and PD measurement. His question now: what other methods can be used to carry out both SB and PD measurements? Other methods he's asking for conducting SB and PD measurements.
The abbreviation, I didn't get it. What does it say? AC measurement, or what are you?
SB,
what did you...
high voltage and PD.
Okay. Maybe I didn't get the point, but definitely you need electrical field, and therefore you need a high voltage. And to start the PD activity, without high voltage, you will not have any PD activity. Maybe I understand the question not correctly, but you have to use first high voltage to apply to start the PD activity, and then you can detect it. Maybe it's the wrong answer. Sorry.
Okay. Anyway, I'll ask you to contact once again. Next question from Lina: how the PD measurement voltage as well as pre-stress voltage is calculated on different equipments? How the PD measurement voltage as well as pre-stress voltage is calculated on different equipment?
For the on-site, for the commissioning test, it's automatically included in the standards, because every voltage stress which is higher than the operating is consuming a little bit of the life of the equipment. That's the point, I guess, you mentioned. So if you like to go make monitoring, then definitely you have to ask the utility and the supplier of the equipment if you are allowed to stress or to apply a higher voltage for PD monitoring, also after repair, than just a normal operating stress, because this is exactly your point. And then you only allowed to have the normal rated voltage applied and measure the PD. Be careful if the system is under operation for several years to apply a higher voltage stress than rated. You have to ask a supplier or the utility if it's allowed.
Thank you. Next question from Mr. Lalit Titodia. How can we reduce the unwanted resonance from source generator? Then which parameters is mandatory to control external signal? The second part, which parameter which is mandatory control external signals suggests, is asking this. How can I reduce unwanted resonance from the source generator? That is the first part of the questions.
What does he mean by unwanted resonance? From the point of view of a resonant test system or other resonances?
From source generator. How can you reduce the unwanted resonance from source generator?
Maybe I didn't get to the point. If you have a transformer, then you have the same frequency. If you have a resonant frequency system, then you cannot change the physics. Then the frequency will be lower, definitely, due to the high capacitance. That's a fact. Or you have to increase inductance, and then you need a resonant test system with very inductance in addition. But this is not realized very often.
Then next question, which parameter is mandatory control external signal? Question not that clear. And I will ask him to give the query again. Now the question is from Soumya Roy again. What has been the experience of UHF PD for transformers? What has been the experience of UHF PD for transformers?
This is now under discussion practically and also in D1 and A2. And as I mentioned, there will be maybe this year or the beginning of next year, there will be a publication about the UHF. UHF means in a transformer range up to several tens of megahertz, in some cases even higher. Again, it's not a standard. Yeah, can be done in addition. It's not harmful for the device. But again, it depends strongly on the design of the transformer, how sensitive this is. And this is one of the reasons that this technology is not still mandatory. It's just an addition. And yeah, again, I have to refer to the literature. Sorry.
Next question from Mr. Nandish Kumar. What are the measures to avoid external noise during online PD measurement?
One would, if one big advantage is to change the frequency. That means if you have a resonant test frequency, for example, as I said, if your GIS or the cable is directly connected with an air insulated substation or power line, then and maybe the substation around is still in operation, and maybe you have a lot of external PD at 50 Hertz or 60, then if you have another frequency, then clearly you can extinguish definitely external internal noise. That's one big issue and one advantage of the resonant test system. The other thing is grounding or filtering of the power supply. And the other thing is for in the PD equipment itself, if you go to higher frequencies, not according to the conventional, let's say 1, 2, 3, 4 megahertz, which is normally applicable with the PD equipment available, then you can try to exclude the external noise because they normally have lower frequencies than 1 or 2 megahertz. This is one possibility.
Thank you. Next question is from Mr. Gautam. What has been the experience on on-site UHF PD monitoring of transformers? Has it been adopted worldwide by utilities?
I can't answer this. Honestly, I don't know if it's really applied worldwide as a standard, but they are playing around with it. I have no experience about that. Because I'm D1 and not A2, so D1 is dealing with materials and techniques, and I can't answer this. Sorry about that, because I don't have no insight by myself what they are doing right now.
Okay. Now next question from Ereda, and is lightning impulse or switching impulse test is recommended for on-site testing as condition monitoring? Is lightning impulse or switching impulse test recommended for on-site testing as condition monitoring? If yes, what is the test voltage and is the waveform same as mentioned in the standard? Anil Kopar from it.
Yes, to my knowledge, it's not necessary both for GIS and transformers. It can be done in addition. it's not recommended because, as I said, it's you need much more equipment. For a GIS, it's due to the higher capacitance, you normally accept oscillating lightning impulse or oscillating switching, and the values and the frequency component is defined in the standard 660-3, and this has to be fulfilled, but it's an add-on. The reason behind it, the different defects behave different to the different frequency range. And you can imagine that an impulse has a much higher frequency component, and this has an influence on the field distribution inside the equipment, especially in the transformer. And that is one reason that the transformer is factory tested with chopped wave, because the AC frequency has a different field distribution than the chopped wave. But to my knowledge, there's not a must for both. For transformers, you have to be careful. I have not direct experience about that, but I know that the working group right now, the working group which I mentioned, is thinking exactly about that question. If a transformer was repaired or something was replaced, what to do, AC test or whatever, and this is exactly discussed in the working group right now.
Thank you. For next question is from Mr. Mustafa Baz from Samgar, India. As per SIGRE guideline, it is insisted that a PD calibrator and PD test system be the same for JS site testing as was used for factory testing. Do you think that it is feasible for or necessary in that way?
I guess he mentions now the conventional method because there are calibration. Okay, now I will speak technically and not according to the standards. Technically, it might be a slight difference due to the capacitance changes, so that the PD amplitude maybe not just a number 5.5 picocoulomb, maybe it's 4.3 or 6.3. But normally it's not the PD amplitude for maintenance, whatever. You like to see if there's a PD, and then you like to know where is the PD. And the next step is to identify, is it in the joint? Is it a delaminated device in the GS and so on? So physically, it has not big deal. But of course, if there's a standard, normally you have to fulfill the standard, at least for the commissioning test. And if you do it for monitoring diagnostic later on, you can nearly do what you want. You have to be in agreement with the customer, with the end customer. So there might be a slight difference in the magnitude.
Okay, thank you. Next question is from Mr. Sunil Kashyap. Which is the best PD test equipment for distribution transformer and cable joints in RMU, basically for distribution field? Which is the best PD test equipment for distribution transformer and cable joints in RMU?
There is no best equipment. Depends on slide. If you have on my presentation, so slide number 9, if you can show it, maybe it's possible. With my presentation, I guess you have the PDF file in front of you, or at least, can you show it, maybe?
Number 9, I think not possible to number 9. I'll just try.
Slide number 9, slide 9.
Visible now something?
Physical effects of PD. This one, this one.
Yeah.
And
okay.
A little bit down, please, or full screen. Yeah, and here you see why I can answer is because if you look at the bottom, you have the PD, the device which analyzes, but this depends on the discharge itself. It's a hopping particle. Is it a delamination? Is it a void inside a transformer? Then it depends on the way, the distribution and traveling of the wave to the sensor. And then, like the UHF questions several minutes before, which UHF sensor is suitable, and then this defines the sensitivity. And therefore, there's no reason to define this equipment or this is better. You have to look at the whole path of the signal. The only question which the only point which I can answer is what kind of equipment do you really need? A very easily one, which makes analyzing simplified, or do you need an equipment which you can use for basic scientific investigations in a research lab, where I have worked for several years? Then I would say, okay, this kind of equipment would be better suitable and the other one not. But in general, it's not possible. It depends on what you like to see. Sorry, I cannot say company A is better than the other one.
Dr. Love, can you put on your video? Possible?
Pardon?
No.
Yes. Yep.
Yeah. Yes. Now, next question is from Lina. Why allowed PC level varies with the different types of dielectric medium? Lina from CPRI. This from CPRI, India. Why allowed PC level, picocoulomb level, varies with the different type of dielectric medium?
Again, so I look at my slide. For example, if you have a gas insulated substation, then it's quite easy. It's you have a gas, and gas can exchange itself quite easily over time, and so the discharge is in an inhomogeneous field, so you can accept a little bit higher PD levels, like 5 or 10 picocoulomb. If it's polyethylene and you have a defect inside the polyethylene insulation, and you can pick it up, and 1 picocoulomb could be definitely dangerous and will kill your cable in 1 hour, 2 hour, whatever. So that's the reason the PD activity and the damage produced by the PD depends strongly on the material of each PD discharge. So a gas is more resistible, and like our ceramic insulator, support insulator, is more robust against PD than a polyethylene cable, which is the one which doesn't accept any PD normally. And that's a big difference, that, for example, for transformers, a PD level of about 100 picocoulomb is allowed, in GIS about 5 picocoulomb is allowed, and for cable 1 or 2 picocoulombs are allowed, depending on the standard. It's physics behind.
Yeah, thank you. Dr. Mr. Ralph, only again same question. Is there any, Mr. Lokesh Kumar Sharma, his question are answered. Apart from resonant frequency method, is there any other method to carry out both SB and PD measurement? Apart from the resonant frequency method, is there any other method also? That is the question. To carry out both SB, high voltage, and PD measurement.
I don't know.
Okay.
Would be interesting.
Yeah, okay. Now next question from Mr. NG Patel. ACRF is the best power supply for testing any limitation or thereof are left over, and I'm not able to clear. ACRF is the best power supply for testing any limitation thereof or left over. I think not that clear question.
Yes, if you go back to, okay. Your voice is. I couldn't understand you. Sorry. It's too low. Your voice is too low. Now I hear a lot of noise.
Dr. Muni, your voice is not audible.
It's not audible. Is it audible now?
Yes, fine.
Okay. Now, any queries now? A lot of questions are there in the chat box, and Dr. Larf is readily answering those questions. Any message for the participant from your side, organizer side?
I think may we conclude within 10 minutes. So
okay, we will try to complete in a short time. Okay. Okay. Now, Dr. Love, this one more question. What has I think Mr. ACRF is the best power supply. You are trying to answer the question. Is it still something you answered or to be done?
Page 15. Show please page 15.
Page 15
of my presentation. 15.1.5.
1.5. Yeah.
This one. And the reason for the resonant test frequency for the invention of using now it's very noisy. Okay.
Now it's
okay. Was for using semiconductor devices was to test high capacitance. And that's the big advantage. It's shown in the so-called quality factor. Especially for long cables, you need a lot of power. As I mentioned, several MVA up to 100 MVA if it's 40 kilometer long cable, for example, and high test voltage, because the power is increasingly with the voltage and the capacitance and so on. And that was the main background for that. Of course, if your cable is quite short, let's say 1 kilometer or so, then you can definitely use also maybe a compensated transformer or whatever, if it's available and if you have the power available on site. And due to the Q factor, which shows the test power, and it's much more reduced by a factor of 100. So that means if you even only in parentheses need 1 MVA and you use a resonant test system, then 10 kVA is sufficient. So you can get it right off the power supply. You have it in your house, so to say. And that is a big advantage why using resonant test system. It has nothing to do with the test object itself. It has only to do with the capacitance and the power you need.
Okay, now next question from Soumya Roy. Is there any method for detecting the incipient partial discharge inside an underground cable with very high accuracy?
Again, depends on how the cable is located. If it's a subsea cable, then it's very tricky. There are different technologies, and this is again mentioned in, let's say, if you go, I'm just looking. That's not mentioned in my list. There's a technical brochure of B1 which exactly describes, this was published, I guess, last year, and how to proceed. There are different steps needed and different technologies are needed. Not only high voltage sources needed. For example, it's much easier if it's a land cable. Then you have, if you really have to pinpoint, then first you get a rough estimation by time domain reflectometry, and could be plus minus 100 meter, for example. And then, but it's too high, then you have to go on site, like in the landscape, and then the other techniques available to pinpoint. There are magnetic sensors and so on and so on. And these are described in this mentioned technical brochure of B1. It's fault location, it's the title, and you will find it directly on the website of SIGO if you type in B1 and fault location. And this has a lot of details described how to pinpoint a defect in a cable. Sorry, that's my answer.
Next question from Mr. Vishal Modi. If power transformer is facing very high PD, then how to reduce it or diagnose it? If power transformer is facing very high PD, then how to reduce it or diagnose it?
If you don't do anything with equipment that's now I'm making kind of joke, you have to reduce the voltage, then the PD activity is going down. If the PD activity is inside the transformer, you have no chance to reduce the PD activity. As I said, PD, or the physical main background for partial discharge, is the electrical field and not the voltage. This is always very, very important. Even if in a smartphone like this one, you have higher field stresses than in any power equipment you have. Why? Because we have a micrometer scale with 3 or 5 volt. So the electric field is really the main reason for that. So if you can't change anything physically of the transformer, let's say like the shielding of the bushing or whatever, then you have no chance to reduce the PD activity unless you repair or replace some parts. Because the only thing is you have to reduce electrical field, And this is only possible if you reduce the voltage, but this is not possible normally.
This is last but one question. One is how to pinpoint PD location for directly buried cables without excavating. How to pinpoint PD location for directly buried cables without excavating. The second part of question, how to pinpoint the PD source after excavating the area of the PD location indicated by time of arrival method.
Mm-hmm. I guess the first part of the question was for offshore cables. Offshore cables?
Yeah, without excavating. How to pinpoint PD location directly by cable without excavating.
Now I have maybe to change my head. There are different possibilities. One is by the company where I'm working for. This is not new, but if you normally you have access to dividers or to the bushing, and if you have a breakdown, you can use this breakdown for fault location. Why? Because this produces a very big and steep impulse, du after dt, or d as a current change in a very steep range. That means microseconds range, and due to the speed of the wave on the cable, about 150 meter per microsecond. So if you have a time resolution of a little bit better than 1 microsecond, half a microsecond, then you can pinpoint maybe to several tenths of meter, but not more if the cable is very long. If the cable is shorter than 1 kilometer, then you can pinpoint to several meters. If it's done, so you don't even need an additional equipment, you do it right now, like monitoring, and you pick up the breakdown and you look at the signal, the traveling, because it's reflecting back and forth several times. And by that, you can, if it's a short cable, pinpoint within some meters. If it's a long cable, more than several kilometers, then plus minus the length of the cable plus minus 5%. In some cases better, in some cases lower. Depends again on the design of the cable, the damping behavior, and so on and so on.
Okay, I think almost all questions over.
But you have to bury it.
Yeah.
No.
So some more questions are there. Maybe how to pinpoint PD source after. I think you answered most of them, sir. And I thank all participants and actively participating, putting question answer, and also Dr. Ralph for patiently presenting as well as answering all the queries. And thank you very much. He has nearly 30 years experience in this area, and we are benefited, whole community is benefited by his experience and his presentation. Now over to organizer. Now I request Mr. A.K. Bhatnagar to give vote of thanks for this meeting.
Dr. Ralph.
Sigre India, can you please?
I request Mr. E.K. Bhatnagar, Director Sigre India, to pose vote of thanks. Sir, please.
Thank you, ma'am. And thank you, everybody. Good afternoon. Ladies and gentlemen, I am Ajit Bhatnagar. It is my privilege to propose a vote of thanks. It was a very important topic we have touched today, high voltage on-site testing and partial discharge. And this is organized, as you know, we have organized CGRE and CBIP together. We did this, and I must thank Ralph, our chairman of CGRE Study Committee on G1. And thank you very much, sir, for your support and association with us and giving, your thought process, your experience sharing, and for agreeing to our request on such a short notice for delivering a tutorial. This enriched all our participants, sir. Sir, we have around more than 110 participants participated today. So thank you very much for your kind time. And this is how you are supporting us through this program, and all the eminent speakers joined hand with us and for this tutorial. And we will be doing again in November and December too. So Thank you for all the participants who have given time, took knowledge, share your thoughts, and you can send your feedback to us. And if you have any suggestions or anything in your mind, chat box is always available for you. Kindly share with you. And we are also grateful to Dr. Muni from BHL, GM BHL, for your kind support to us, sir. And we are very much thankful. The sharing of your knowledge is great support to all the participants attended this program, sir. And you are also a National Study Committee on D1 chairman. And sir, we are also thankful to Secretary CBIP for giving us time. And my sincere thanks to Sam Gaw, India, and Mrs. Artrova for their excellent support as a sponsor. Thank you very much, sir. Thank you very much.
Welcome.
Thank you. Thank you, sir.
At the end, convey our gratitude again to Dr. Raul, Chairman SIGRE Study Committee D1, Dr. BP Moni, GM BHEL and National Representative for the Society, Mr. Mustafa Baj from Samgor, India, Mr. A.K. Dinkar, Secretary SIGRE India and CBIP, Mr. A.K. Bhatnagar, Director SIGRE India and CBIP, for their presence. We also once again convey our sincere thanks to all the participants for joining us, and we will see you next time. Once again, our humble request to all of you, kindly consider becoming member of SIGRE for regular interactions and associations. So I thank everyone for joining this tutorial. Thank you.
Thank you, sir.
Thank you.
Thank you very much.
Okay, so I will leave
Thank you. Thank you, sir.
Thank you. Bye-bye. See you next time.
Thank you, sir.